Good morning, all of you. Can you hear me?
Yes, ma'am.
Now, can you hear me?
Yes, ma'am.
So, we have seen some metals have a tendency to lose electron. We say they are highly active, reactive metals. But in some other case, metal ions are ready to take electrons. In some cases, metal is ready to lose electron. We say they are undergoing oxidation. Oxidation is removal of electrons. Some metals have a tendency to lose electrons. We say they are undergoing oxidation or they are good reducing agents. But in some other case, metal ions are ready to take electrons. We say they are undergoing reduction. Metal ions are undergoing reduction. Metal ions are undergoing reduction. So they are not good reducing agents. Moreover, you can say they are means as you go up in that electrochemical series, down one Zn2 plus slash Zn. Good reducing agents on the top that is fluorine, good oxidizing agents. Down ones will undergo spoilage, they will undergo oxidation. Down ones undergo oxidation, top ones undergo reduction. Top ones ions will undergo reduction. Top one metal ions will undergo reduction. So one is giving electron and the other species is taking electron. One species is giving electron and other species is taking electrons. So electrons are moving from one place to the other. When we dipped that iron nail in copper sulfate, the test tube became warm. That means electrons were flowing, but we were unable to use this electron to at least to light a bulb. Now we are going to make this electron pass through a wire and will be connecting a bulb on the wire and the bulb will be glowing. For that, I am separating zinc to one portion and copper to the other portion. Zinc rod dipped in its ions, dipped in zinc sulfate solution or Zn2 plus ions. So here I am making the test tube one, I am separating into two different half portions. That is here one zinc rod dipped in zinc ions. Which sentence ZnSO4 dissolved in water that contains Zn2+. Three possibilities here. Zinc can change to Zn2+ ions and fall into that solution. Zn2+ means not in the metallic state, not in the solid state. Zn2+ means it is getting dissolved, it is flowing away, it is lost, it is oxidized, we are losing the metal. Zinc returns in zinc sulfate. This is one possibility. First possibility I am telling, this will dissolve. Second possibility, this will get deposited. Third possibility, nothing happens. So something will, out of these three, something will be happening here. One possibility, nothing happens. Second possibility, zinc rod gets dissolved into this solution. Means zinc atom is changed into Zn2+, means we are losing the metal. Metal is changing into the liquid format. It will flow away, it is useless for us. Third possibility, from the solution, Zn2+ ion will get enhanced to this rod as Zn atoms, and so many atoms, when they are getting stuck to this thing, it becomes thicker and thicker. When zinc dissolves, it will become, zinc rod becomes thinner and thinner. Alright, so these three possibilities are there in our minds. This is connected to another beaker which contains copper rod dipped in soda and copper sulfate solution. Copper sulfate solution. This a glass tube in which a semi-solid substance, gel glass tube for electrical connectivity without mixing these solution, and it gives the neutrality of this solution to keep the neutrality in the cell. Now, this rod is connected to a bulb. To the other rod, copper rod. After this connection, the bulb will glue. The bulb will glue. So actually, this is a cell. We call it as galvanic cell or electrochemical cell. What do you buy from the market? Nippon or Eveready, Panasonic. That is this thing only. This is in a compact form. And you don't see such two separate cells and all. Everything is in a compact way. It is fitted, sealed. On that it is written 1.5 volt. When you buy a cell or battery, it's written 1.5 volt. Daniel made this cell. This is called Daniel cell. Every cell which is connected with one portion to the other, that is called a galvanic cell or electrochemical cell. The first cell was made by Daniel. So this cell, the zinc sulfate and copper sulfate, that is called Daniel cell. The outcome, what is the outcome? The glowing of the bulb. If you put this cell in that compact form in a torch, you can light that bulb of the torch. Or if I want to know what is the voltage available from here, is it 1.5 volt or something else? Daniel noted that when he connected a voltmeter here, it read for 1.1 volt. Daniel got only 1.1 volt. Now in market, that's what cell is available to 1.5. So in Daniel's cell, the output, what is that output? The difference between the potential. We know that water flows from higher level to lower level. Electricity flows from higher potential to lower potential. Of course, in our electrochemical series, copper is at higher potential, Cu that is plus 0.34 volt, and zinc is at lower potential, Zn2 plus slash Zn minus 0.76 volt. How these values are obtained that we will learn afterwards. So, the voltage is 1.1 volt, that is the outcome, the results, that is the difference between these two halves. This is called a half cell, this is called a half cell, and this is called a complete cell, Daniel cell, galvanic cell, or electrochemical cell. The difference is right there. The difference is right there. Difference is given by E naught cell at standard condition, means 1 molar solution here, 1 molar solution, 25 degrees Celsius, standard condition, 25 degrees Celsius. That time, what we read from here, that is a standard E naught cell. Either by putting a circle or one line inside the circle, that is standard condition. If you change the concentration, this value will be changed. If you change the concentration here, the value will be changed. That you will study that equation, equation you will study in next year. So E naught cell is equal to, the equation is given by E naught cathode minus E naught anode. Now what is cathode, what is anode? Before that, let's see what is happening here. When these two half cells are connected, these cells are at different potential. If they are same potential, no current will be flowing, no electricity will be flowing. To flow, there should be a difference, there should be a potential difference. Here, what is happening actually? Each zinc atom loses two electrons, and these electrons will be going to that flow of electron from zinc to copper. Zinc will be changing to Zn2 plus, means in a dissolved state, Zn2 plus. Each zinc atom is releasing two electrons and changing to Zn2 plus and falling into the solution. We are losing the metal actually. These electrons are reaching there, these electrons are reaching there, these electrons are reaching there, and here when it reaches Cu2 plus from the solution, each Cu2 plus, there are so many Cu2 plus, each Cu2 plus will be accepting two electrons and get converted into atomic copper atom, that is Cu2 plus will be taking two electrons to form Cu metal. That will get deposited on this. From this solution, Cu2 plus will get deposited on that. So this becomes thicker and thicker. This becomes thicker and thicker. While this becomes thinner, it is deteriorating. It becomes thinner and thinner. It becomes thinner and thinner. And that will become thicker and thicker. This is what is happening. By conventionally, current flows what opposite to the direction of the flow of electron. That means the current flows from this portion to this portion. When the oxidation takes place, that is called anode. Anode, that is a negative electrochemical cell. In electrolytic cell, last year what you learned in that refining of copper and all, that cathode was negative, your cathode is positive. Cathode, that is positive. That is electrolytic cell, this is electrochemical cell, two types of cells. In electrochemical cell, anode is negative and cathode is positive. In electrolytic cell, what you learned in class 10th, their cathode is negative, their cathode is positive. Signs are different. Don't think that cathode is always negative. What is the difference between electrolytic cell, what you learned in class 10th, and electrochemical cell in class 11th? In electrolytic cell, are passing electricity to make chemical reaction. In electrolytic cell, you are making chemical reaction to produce electricity. This is the difference. Ulta, opposite. Here you are producing electricity. There you are producing chemical reaction. Here you are using chemical reaction to produce electricity. There using electricity you are making chemical reaction. That is the difference. Okay. So in this, when you use chemical reaction to produce electricity, anode is negative, cathode is positive. In class 10th, using electricity you are producing chemical reaction, copper 2 plus ions moving from anode to cathode. There is anode, mud and all those things you learned during the refining process. There it is electrolytic cell. This is electrochemical cell. This is also called galvanic cell. Galvanic. You can make so many combinations of the galvanic cell. For example, silver. Cathode you can put as silver. Anode you can put as iron. Fe2 plus Fe iron. So you can select any to make one. The top one you can use it as cathode and bottom one you can use it as anode. You will be getting the electricity. Current is in the opposite direction of the flow of electron by convention. So you will see the deflection in the galvanometer. You can read the voltage of 1.1. So here 1.1, how this 1.1 is read, that is E naught cell, the ultimate, the resultant, the ultimate what you are going to read is E naught cathode minus E naught anode. What is E naught cathode? Which is cathode? This is cathode, copper, that is plus 0.34. So 0.34 plus 0.34 minus, what is E naught anode? What is E naught anode? E naught anode is minus 0.76, which is equal to 1.1 volt. That is what is right there. I told you can make any combination. All combinations are called galvanic cell. But if you take zinc and copper, that galvanic cell is called dynamic cell. So at standard conditions, 25 degrees Celsius and 1 molar consumption, you will read 1.1 volt. So what is the E naught cell? Ultimate resultant. What is the E naught cell of Daniel cell? 1.1 volt. You can change these electrodes, anode and cathode. You can change. You can do any combination. Accordingly, that value will be changed. According to your need, you can change these half cell. This is the half cell. That is a half cell. This is the complete cell. At one portion, oxidation takes place, and at the other portion, reduction takes place. Where the oxidation takes place? At anode. Anodic oxidation, anodic oxidation, anodic oxidation. The electrode at which oxidation takes place is called anode, and the electrode at which reduction takes place is called cathode. So this is an example for galvanic cell. This is an example for electrochemical cell. When you put zinc and copper, then we call it as dynamic cell. This is used to produce electricity. Means you are making a cell, a compact form that is available in the market, and that's small. I told you every Panasonic, Nippon, like that. Our point is oxidation and reduction. Release of electron is called, removal of electron is called oxidation. Accepting that electron is called reduction. This is a half cell, this is a half cell. Now how we got those values? For that, what they did, they took this as a standard electrode whose this value this value, E naught value is arbitrarily given 0. So the difference will be only due to the other one. If one is 0, the difference what you read is only due to this one. And this was assigned as standard electrode potential. That is what is written for the electrochemical series. So this is connected to the cell whose E naught value is to be found out is, that is the cell under investigation. The cell under investigation means this E naught value is to be determined, is connected to a standard hydrogen electrode. We call it as a standard hydrogen electrode. Standard hydrogen electrode, that is H plus an acid is taken, H plus is 1 mole of X, we have 1 mole of solution, and it is connected to a platinum wire which is connected to a platinum coated with platinum, this sheet coated with platinum, and this is and hydrogen gas is passed through this. Hydrogen gas H2. H2 gas is passed through this. So there, in the case of the copper, when we connected copper species we have given, Cu2 plus we have given. That is metallic form and oxidized form. Here, this is the oxidized form and this is the elemental form. Elemental form, oxidized form. Okay, H2 can be converted into X and H to atoms. So elemental form we are giving, oxidized form also we are giving, and 1 mole of solution at 20 degrees Celsius. Both we are giving. Here also both the species we don't know what is going to happen, whether the metal will dissolve or whether that dissolved ions will be getting converted into the metal atom. So we are giving both. We don't know what will be happening. So this H2 species we are giving, means elemental form we are giving, oxidized form also we are giving. Now this is called SHG. SH is standard hydrogen electrode, whose E naught value is assigned as 0. This is 0. That is 2x plus slash x2, 0.000, 0.000. So, if this is 0, the difference what we read is only due to this. So, the cell whose E naught value is to be found out is connected to SH standard hydrogen electrode. And from this value, what we are getting, that is only due to this. This is the E naught cell. E naught cell is equal to E naught cathode, 0 minus E naught anode. So what is read from here? From that you do the calculation and you fill this electrochemical series. That is how we find out the standard electrode potential. The standard electrode potential. What is written on that electrochemical series? Here I connected zinc dipped in zinc sulfate and I want the value like this. If I want to find out this copper dipped in copper sulfate, instead of this I will connect that copper dipped in copper sulfate. I will dip that copper dipped in copper sulfate and I find out this difference. Again I use this equation, E naught cell is equal to E naught cathode minus E naught anode, which is cathode, which is anode. From this deflection you can make out. And you find out the E naught value of copper and you write here the electrochemical series. Like that, so many electrodes are connected to SHC and their E0 values are found. Now, let's see. When zinc contains zinc sulfate, when it is connected to this thing, you are getting what? Minus 0.76. What we are reading is 0.76. E0 cell is equal to E0 cathode minus E0 E0 cathode. E0 cell, that is 0.76. E0 cathode, that is 0.000 minus E0 anode. What is E0 anode? Z2 plus slash Z. Right? Then what is E0 Z2 plus slash Z? That is minus 0.76. E0 Z2 plus slash Z is equal to minus 0.76. I got the single electrode potential that I have written in minus 0.76. So in this way, you can find out the single electrode potential. For that, what you have to do? Connect it with SHE. Connect it with SHE. What we are reading from here is the difference, and we arbitrarily taken as the SHE's value, that is 0.000 volt. So you got minus 0.76 volt. That you are right. What are the anode reactions here? Anode reaction. And what are the cathode reactions? At anode, oxidation takes place. That is Zn changes to Zn2 plus 2 electrons. Then reduction takes place. Here this is oxidation, there it will be reduction. Reduction means H plus, take one electron forming H, completing that H will not stand like that, so this will be H2, so here it will be 2H plus 2 electrons gives H2. This is the reduction equation. This is oxidation half, that is reduction half. For the complete cell reaction, you have to add left to left and right to right and cancel the common things. So I am doing the overall reaction. Overall reaction is Zn plus 2 electrons gives Zn2 plus 2 electrons plus H2. So 2 electron got cancelled. See, I added left to left and right to right. So the overall reaction is Zn plus 2H plus gives Zn2 plus H2. If it was in the Daniel cell it was Cu2 plus 2 electrons gives Cu. For Daniel cell, what is the overall reaction? For Daniel cell, Zn changes to Zn2 plus 2 electrons, and at reduction, that is Cu2 plus 2 electrons gives Cu. This is the oxidation, and this is the reduction. What is the overall reaction? Overall reaction is equal to what? Add left to left and right to right. That is Zn plus Cu2 plus 2 electrons gives Zn2 plus 2 electrons plus C. This got cancelled. So what is the overall reaction? Overall reaction is Zn plus Cu2 plus gives Zn2 plus C. Thank you.